Hi guys, welcome to C3 Warm-Up 1, Mr. Smith's Guide to Algebraic Fractions. So the first one is an easy one. I'm going to simplify 3x squared minus x minus 2 over x squared minus 1. So that's a bit of good old factorisation on the top and bottom. So on the top I get 3x plus 2 x minus 1. And on the bottom a difference of two squares, so x minus 1 x plus 1. So I can cancel those two, and so I get 3x add 2 over x add 1, and that will typically gain you 3 marks. Now this is show that x squared plus x minus 1 is greater than 0 for all x. Now this means the answer to that question has to be greater than 0, so the range of the function y equals x squared plus x plus 1 is bigger than 0 for all x. So, to show that something's positive always, it's complete the square. So, I do x plus 0.5 squared, take away 0.25 plus 1. So, I half the 1 in front of the x, and I take away that number squared. So, I end up with x plus a half squared plus 0.75. Now, that means that this function is always bigger than or equal to 3/4, because this is positive, so positive add 3/4 is at least 3/4, and 3/4 is positive obviously, so we get always positive for all x greater than 0. Now number 3 is a division question. Okay, so I'm going to divide 2x to the 4 minus 3x squared plus x plus 1 over x squared minus 1. Now, I do this by long division. So we get 2x to the 4 plus 0x cubed minus 3x squared plus x plus 1. Okay. Now, I haven't said at any point if this exactly works or not, so we don't know what kind of answer we're going to get. We might get a remainder, which we'll deal with. Right, first of all, I say how many x squared minus 1's go into 2x to the 4. So how many x squared go into 2x to the 4? So that is obviously 2x squared. And I take away what I've used up already. So I take away 2x squared times x squared minus 1. So I take away 2x to the 4. Okay. And I take away 2x squared. So I take away 2x to the 4, I get nothing, and I minus, which is minus x squared. Okay, and I carry on plus x squared plus 1. Now then I see how many x squared minus 1 go into minus x squared plus x plus 1. Now that is obviously minus 1 lot, because I wanted to know how many x squared minus 1's went into minus x squared. So how many x squareds go into minus x squared is minus 1. And now I take away what I have used up. So I've used up minus 1 lot of x squared minus 1, which is minus x squared plus 1. That means I finish off with that, take away that, so I get minus x squared minus x squared is nothing, plus x plus 2. So I'm doing 1 minus, plus nothing. So I end up with x for that question. So my remainder is x. So my answer to the division is 2x squared minus 1, and a remainder of x, which you can write as x over x squared minus 1. Okay, now the last one. This looks a bit of a harsh question, so I'm doing that, take away that. Now my first step, I think, is to factorise where possible, because that could get really, really, really arduous if I don't spot any factors earlier. So on this one I go x 2x add 3 on the top over 2x plus 3 x minus 2. Those cancel. Then over here I do 6 over x plus 1 x minus 2. Now I've got a situation where I'm doing x over x minus 2 minus 6 over x plus 1 x minus 2. Now what I can do is the denominator on the first fraction I can make x plus 1 x minus 2, so I times the whole fraction by x plus 1. Now, what we do now is you factorise the x plus 1s. Sorry, you multiply out x squared plus x, and you've got a common denominator, so you say x squared plus x minus 6 over x plus 1 x minus 2. I then will factorise the top, so I get x plus 3 x minus 2 over x plus 1 x minus 2, which means I end up with x add 3 over x add 1. And that is the end of the algebraic fraction session.